Hey guys, it's Mr. Ray here. We're gonna do another lesson tonight or today, on our new topic of trigonometry. So, if you remember the first lesson, we looked at similar triangles. We learned how to prove if two triangles are similar. And if you if you want a quick way of thinking about similar triangles, is basically triangles that have the exact same shape, but have different sizes, and that means their sides are different, but their sides are similar triangles. You could multiply one triangle's side by a number, uh, the same number for all three sides, and the new triangle that you create will be similar. It'll have the exact same shape, same angles, but the ratio of the sides will be the same, but the side lengths will be different. Okay. Um, so we're going to continue with a new topic, and basically we're going to be we're going to be growing this topic for the rest of the unit into other topics. Um, this is sort of related to similar triangles. I'll point that out as we go through it. Uh, but if you go back to the name of the unit, trigonometry, remember we said that that was the study of measurement of triangles, and that really comes down to measuring the three sides and the three angles. So we're going to be looking at some new tools to determine sides and angles, and these ones are pretty cool. You're going to be using these in grade 11 and grade 12 and onwards. Um, Similar triangles, it's kind of you know, it's a topic that we will use a little bit, but not nearly as much as what's coming in the rest of this unit. Okay, so um, this lesson is called tangent ratio, which you'll find out why we're calling it that. But I just want to point out that when we're working on this lesson and the next couple of lessons after this, we're working with triangles that are just only right triangles. So triangles that have a right angle. Okay, and then we finish the unit up where we look at other triangles as well. But right triangles have a special relationship, as you know, based on Pythagorean theorem, and the sides are related that way. So, okay, let's start this off with an example. It might be a little dated by now. Tony Hawk, who is the god of skateboarding, he's probably getting up in age now, but I think he's still involved in the sport. So um, he's designing various sizes of skateboard ramps, and they must have the same slope or the same incline. Okay, and says that each ramp must have a slope of 0.5 or 1/2. And what we want to do is come up with some different size ramps that have the same slope. Okay, so we're not doing these slopes on an XY grid. We're just doing kind of ramps that you could draw triangles for. So the important thing here is at the end here, remember that slope is rise over run. So what that means is each of these different ramps must have a rise over run equal to 1 over 2, or reducing to 1 over 2. So I'm gonna start off simple, and I'm gonna build a triangle. It's going to be a right triangle. So that's basically the ramp. So if I'm looking at this as a triangle, the rise would be this part here, and the run would be the horizontal part. So if it says that the slope must be 1/2, that means I could say, well, if the rise was 1 and the run was 2, that's a slope of 1/2. So there's the first. Now I didn't put any units, but I guess I could say, 1 meter and 2 meters. For now, if I wanted another ramp with the same incline, the same slope, I still have to adhere to this rule here about rise over run. I'll put that out here, is equal to 1/2. But I could make that ratio. I could use different numbers here that can reduce to 1/2. So maybe I make it twice as big, make it 2/4. So this probably isn't exactly um, the same incline, but just pretend it is. So in this case, I could say, well, here's another ramp. So this time, if we made it the rise over run 2/4, that means the rise is 2 and the run is 4 meters. So that would still have the same slope of 1/2, the same incline. And then I could, just extend that, make it like 3/6. So a rise of 3, a run of 6, and then units, of course. So all three of these ramps have the same slope or incline. Um, and if you think about similar triangles, this is where it comes in. All these three triangles would be similar. Their side lengths have the same ratios. Okay, multiply this by 2 and I get this. Multiply this by 3 and I get this. The angles are all the same. Okay, so that's a kind of connection into similar triangles. But we're going to go a little farther with this. So, like we've already said, slope and the angles must be the same for all ramps or triangles, whatever you want to call these. And like I already said, these angles are all the same. That angle, these three angles are the same. These three are all 90, and the top angles will also be the same. Similar triangles. Okay, now I have to do a little thing on names now. Because we're going to get into naming the sides, so that's really important. So here's a right triangle. Try to make it a little more clear. It's not very dark. So if I have a right triangle, we've already got a name for the opposite the 90-degree angle, and we call that the hypotenuse. So I'll just give that a big H for hypotenuse. Okay, so that's nothing new, but we're going to use that name hypotenuse. And the other two sides, before we name them, we actually have to determine what our reference angle is, because we've got two reference angles that are possible. We never use the 90 degrees as reference. It's always one of the other two. So for example, in this case, there's a little symbol down here. I'm just going to make it bigger. And you'll learn about this in a few minutes. This is actually a symbol in the Greek alphabet called theta, Theta, and we use that in maths for unknown angles all the time. So you'll see that over and over again. There's nothing that says we can't use another letter like X or Y or anything you want, but theta is kind of reserved for angles. It's got a special meaning. So if I decided that this angle down here is our reference angle, and I could have arbitrarily said it was this one, but if I pick this angle, then my next side, I'm going to look across the opposite where the angle is, and that's going to be called the opposite side. And then the third side, opposite, obviously because it's opposite the angle, and the third side is called adjacent, ADJACNT. And if you think what adjacent means, it's next to. If somebody sits adjacent to someone else, they're sitting next to them. So this side is next to the angle. Okay, it actually makes up the angle. So does the hypotenuse, but the hypotenuse has a special, it never changes, right? Adjacent will be the side that makes up the angle with the hypotenuse. Okay, now whenever you're naming sides, we can name this one right away. This one seems to be the next obvious one, and then by default, the last one would be A. Okay. Now, if you think about it, if I'm looking at this the way I was looking at these skateboard ramps, okay, up till now we've been calling these sides, if we thought of these as sides, this is the rise and this is the run. So this would also sort of be the rise and this would be the run, but now we're giving it new names. So instead of looking at instead of calling it rise over run, we're going to call it opposite over adjacent. Okay, and that's what I've said down here. So the ratio of the opposite divided by the adjacent side will be the slope angle. It's kind of like the new version of rise over run. Okay, and we have a special name for this opposite over adjacent ratio. We call it the tangent ratio. Okay, and we're going to shorten that to tan all the time. All right, so you're going to see we're actually going to use our calculator. We're going to use that tan button that's been on your calculator all these years, and maybe you didn't know what it was for, but today we're going to use it. And we're going to use it to determine things like unknown sides and angles. So that's pretty cool. So on this example, I've got these 3 points here, triangle ABC. I've got my right angle here, which has to be true for this lesson. It has to be a right angle triangle. And I've got the sides of 6, 8, and 10. We want to know the tangent ratios for the angles A and B. So the way we're going to do that is to let everybody know it's the tangent ratio. We start off with TAN, short for tangent. And we also have to tell, well, which angle are we using the tangent ratio from, because as we saw before, it makes a difference. Maybe I'll just go back to this for a second. So if, like, I arbitrarily decided in this case that that's going to be the angle we're looking at, so I called this opposite and this adjacent. If I decided instead, maybe I want to pick this angle instead, well, that would switch the opposite and adjacent sides, because now if I pick this angle, this side is now my opposite side because it's across from the angle, and by default that becomes adjacent because now it's next to the angle. So hypotenuse never changes, it's always where it is, but opposite and adjacent will flip-flop depending on which of the two reference angles you're going to choose. And remember, you never use the 90 degrees as your reference angle. The reason why we never use 90 as our reference angle is, what side would I call opposite? Because that's going to be hypotenuse, so that's normally where when I pick the angle, the opposite side is normally called opposite, so now I have a problem. So that's why we never use the 90 degree as a reference angle, just other two angles. Okay, so back to this question here. We want the tangent ratios for angles A and B, so I have to specify which angle I'm taking the ratio for. So I'm going to start off with A. So we always say tan A. So now, tan A, that's going to be, I'll just do this in 3 letters, opposite over adjacent. Okay, now when I'm looking from the perspective of A, okay, the opposite side is 6, the adjacent side is 8, so that's going to be 6 over 8, which is 3/4 or 0.75. Okay, and if I looked at the tangent ratio for B, angle B, okay, now the opposite side becomes 8 and the adjacent side is 6. So opposite over adjacent is 8 over 6. So it flip-flops like you see there, but it has a big change on this. It's 1 point. On this one we actually have to round it, right? 1.33, whatever. So sometimes it's better just to leave it as a fraction. And remember, the tangent ratio represents the slope, rise over run. So you could basically saying the slope of this line is 3/4 or 0.75. And if you looked at it from this perspective, the slope of this angle, that's 1.33, which makes sense. This is steeper than angle A. So angle B is going to be bigger. You can tell that just by looking at it. Okay, now we're going to start using to get more interesting information about the triangle, including the sides and the angles. Okay, so find the value of x to the nearest tenth. They've given us the actual angle here. And they've given us one of the two sides, and of course there's our 90 degrees there. So what we're going to do, we have to pick, and we're going to use the tangent ratio for this. Now, we don't really have to call this angle A anymore, or B, or whatever. This angle is 32 degrees. That's given to us. So instead of calling it a name for the angle, we're just going to call it by the actual angle. So this is tan 32 degrees is equal to, so from that perspective of that angle, opposite would be x, and adjacent, maybe I'll just go write the numbers this time. So opposite is the unknown, so it's x, and adjacent is 10. So what we're going to do now is solve for x, and you're thinking, well, how do I do that? Well, the first thing we can do, we can isolate x. To get x by itself, I'm going to multiply both sides by 10. I multiply this by 10, it's gone. The 10 is gone. And if I multiply this by 10, it becomes, you write it as 10 tan 32 degrees. Now, it's kind of important that the number part that you're multiplying this by goes in front. So the 10 went in front of the 10. If I'd written it as tan 32 times 10, you might think, well, am I multiplying the angle of 32 degrees by 10? But, and that's valid. That's a valid question, but you're not multiplying the angle, you're multiplying the ratio. So the number you multiply, think of this as like glued together, right? So if you're multiplying by something in front, it multiplies with this number. Now, here comes, you can get your calculators out. Okay, so you can see here I've got this tan button. Okay, now one thing you have to do, one thing about angles you're going to find out is there's different units we can use for angles, and I know that's probably a surprise because we, up till now we've only measured angles in degrees, and that's mostly going to be true. But there's another unit we use in grade 12, and that's called radians. And if you notice down here, I've got a button here, rad, that stands for radians. If I push that, and everyone's calculator is going to be different, you can see it like a rad at the top or an R. Okay, now if I press it again, you can see that button change to DEG for degrees, so it kind of toggles back and forth. You want to make sure you're on degrees. Okay, now mine doesn't show DEG or D up here, but most calculators will have that. So it's very important to use that. It's kind of the difference between, measuring temperature in Celsius and Fahrenheit. It's the temperature feels the same, but it's just using different units. Okay, so make sure you're doing that, otherwise the calculation is way off and you'll get frustrated for sure. So what we're going to do here, let me move this up so I can get the calculator. Okay, so to do this whole thing, now everyone's calculators are different. So if I want to take find out what tan 32 is, for me, I press 32, so I put the degree and then the tan button, and then I get this long decimal. So we're not going to round and then continue on. So that's what tan 32 is, and now we multiply that, which is this number here, by 10. So times 10 equals, and that's 6.24. And of course we're going to, it says here round to the nearest tenth. So that means it's going to either be 6.2 or 6.3, depending on the next digit. And that isn't big enough. It should be 5 or more to round up. So that's going to be 6.2. And I guess there's no units on the 10, so I can just call it units. So we know that if that's a 32-degree triangle and that side is 10, well, that's going to make that side 6.2. Okay, so we've figured out our first trig calculation. to find an unknown side length using one of these new buttons on the calculator. Okay, so let's try another question. So more of the same, really. Find the value of x to the nearest tenth. Same as before. This time, I've got two sides here. I've got a third side, and I'm trying to find out what that side is, and I know this angle is 46. Now, I think when I made this question, I wasn't being overly accurate. So one of the ways that you could actually solve for x is to use Pythagorean theorem. Okay, and normally that would work just as well, but I don't think I think my measurements were a bit off here. So normally you could do it using trig, or you could use the Pythagorean theorem and get the exact same answer. But in this case, it doesn't quite work out that way. So if you try it and it doesn't work, that was my issue, not yours. Okay, so now we look at the angles we've got here. I don't know this angle, but I know this angle. So that's our reference angle. Remember, we never use 90. So if I'm naming these sides, well, this is opposite, this is hypotenuse, this is adjacent. Okay, now if I want to know, if I want to get that angle, I definitely have to include the opposite side, and I could either use this or this side, but we haven't, all we know now is this tan ratio. So I'm going to start writing my formula. So the tan of 46 degrees is equal to opposite, so that's x, over adjacent, which is 16. Okay, so this looks a lot like what we just did before. We're going to multiply both sides by 16. I'm going to flip the sides around, so it's going to be x equals 16 tan 46. A lot of times after, if you forget the degree sign, no big deal. But I think it's a good habit to start off, so you realize, oh, that's an angle there, and not like a side length or something. So back to our calculators. So this time we're going to make sure we're on degrees, 46 tan. Now on a lot of your calculators, it'll be opposite. You'll press the tan button, and then 46, and then equals. Okay, so you'll have to figure that out on your own. But usually the better calculators are the ones where you would put the tan first. Okay, so that number here, 1.03, that is tan 46, and now I'm going to multiply that by 16, and I get 16.56, and this is again rounded to the nearest tenth. So the tenth would be the 5, so it either stays at 5 or goes to 6. In this case, it does jump up because the number to the right is 5 or higher, so it's going to be 16.6 units. Okay, and one thing you can always do, you know from Pythagorean theorem that the hypotenuse is always the biggest side, right? So if you see what the hypotenuse is, and then you calculate, the other side here to be 16.6. Well, that seems reasonable. It looks like it's about half of that. But if you got a number like 42, well, you should know that it can't be higher than the hypotenuse. So if you got something way off like that, hopefully you'll stop, see what you did wrong. Maybe you're on radians. Maybe you did something wrong here. Now, the other thing I want to point out too is, you notice I didn't do any rounding until I got to the very end. So that number we got when we did tan 46, I didn't write it down. I just kept on going and multiplied by 16, and then rounded at that point. Okay, so that's your goal in math should be, if possible, only round your answer at the end. Otherwise, the more you round, the less accurate it will be. Okay. One more similar type question. So this time we've got an angle of 50 in this corner, we've got a side of 8 here, and value of x, that's the side we want to find out. So I'm going to use tan. So if I'm looking from that perspective, that's the opposite. and that's the adjacent. So tan of 50 degrees is equal to opposite over adjacent, 8 over x. Okay, now you have to be careful with this because it's not like the ones we just did. Let me show you that. So the other ones we did had the x on the top of the ratio. And all we had to do was multiply both sides by the number on the bottom. Well, I can't do the same thing here. I can't multiply both sides by 8 to get x by itself. If I multiply this by 8, I get 64 over x. So there's a couple ways you can do this. The way that I think works best is we're going to multiply both sides by x, which is something we don't usually do, but in this case it's going to work. So if I multiply this side by x, it ends up canceling the x on the bottom, so I just get 8. If I multiply this by x, I just put an x. I multiply tan 50 by x, like that. And remember, the tan 50 is glued together. It's not two separate things. This is a number that we'll figure out in a second. So if I want x by itself now, I want to get rid of the tan 50. So right now x is multiplying with tan 50, so we're going to divide both sides by tan 50. I'm going to get x equals 8 over tan 50. So this one's different than before because we weren't dividing by the tan calculation before. So you have to be a little careful with this one. Everyone's calculators are different, so sometimes you're going to have to put brackets. Let's get my calculator going here. All right, so in this case, I'm going to do, so for my calculator, I don't need brackets, but sometimes you will, okay? So it's going to be 8 divided by, and I'm going to press 50 tan. Where's tan? Now that's not the answer there. That's tan 50 right there, so I have to press equals, and then I get the final answer, 6.7, because I don't round up. So 6.7 units again. And does that make sense? 6.7. Yeah, well, the ratio might be off a bit there, but it seems reasonable. It's not like I got 45 units or 1 unit. It seems to be in the same ballpark, so that seems right. All right, and now we get on to the last little topic, and this is where things get really cool. The last 3 examples, we're finding unknown sides. So how does it work to get an unknown angle? Okay, well, we're still going to set it up the same way. We're going to do a tan equation, and we're actually going to do something called, if we read this, finding the unknown angle is done by using the inverse tan function. Okay, so, and that's what it's actually called, the inverse tan, or tan inverse. This is commonly known as, now when you see it written, it's kind of weird the way they do it. It's tan, and it's got a little superscript like an exponent with a -1 there. Okay, that doesn't mean tan to the power -1. It just means tan inverse. Okay, so that's the way it's written like that. So it's still going to be, yeah. So how do you do tan inverse on your calculator? Well, I'll just show you where the button is, and then we'll do a calculation that uses it. So, okay, you notice if I go down to this area, I've got my tan button. Now the next lesson, just to give you a little heads up, we're going to learn these 2 functions, sine and cos. But where's tan inverse? So usually, well, just about every calculator I've ever seen, it's like the second function button of the tan. So if I want to get tan inverse, I press second, as in second function, and you notice the button changed to tan inverse. If I flip it back, it goes back to tan. Okay. So let's get this going. Let's see how it works. Okay, and here's that symbol I talked to you earlier about, theta. So that's the unknown angle. That's what we're trying to find. And we know this side is 12 units and this side is 5 units. Based on that ratio, well, we could actually get the slope, right? The slope would be opposite over adjacent. The slope would be 5/12. But we want to convert that slope into an actual angle in degrees, and that's exactly what the tan inverse function does. It takes a slope and changes it into an angle. Okay, so I'm going to start off same way I did the other questions. So tan. Now this time I don't actually know the angle. The angle is unknown. We're using theta, so I use tan theta. Okay, now that's going to be equal to, so because theta is the angle, that's opposite over adjacent. So if you think about it from that perspective, that's my opposite, that's my adjacent. So it's going to be 5/12. Okay, so how do you get that by itself? A lot of people think, oh, don't you just divide both sides by tan? That doesn't work. Tan isn't a number. Tan is a function. Okay, so tan is like a square root. Okay, so if I said the square root of x is equal to something, you wouldn't divide by square root. You do the inverse of square root. Okay, which would be squaring. And in this case, the inverse of tan is tan inverse. So I'm going to take the tan inverse of both sides. So I'm going to put brackets here. This looks probably look a little funky the first time you see it. So I'm taking the tan inverse of that, and that's going to be equal to the tan inverse of 5/12. I'm just doing the same thing to both sides like we always do when we solve equations. I'm undoing the tan function with the tan inverse. Okay, and what happens here, this would be like squaring a square root or multiplying something you just divided. These two things just cancel right out. Okay, and I'm left with theta equals tan inverse 5/12. Okay, so all we have to do is figure out how to get that, and we've got our angle. So let's try that. This up. Okay, so the first thing we have to do is actually do this. So we have to do 5 divided by 12 equals. Okay, so basically that's, you could write theta equals tan inverse of this whole thing, but again, why bother? Let's just do everything in one step. So now what we have to do is do the tan inverse of that. So remember, to get tan inverse, at least on this calculator, you do second function, and then the tan inverse is there, and we get our number, and this is going to be, I guess it doesn't say how to round it. Usually when you round angles, it's to the nearest degree, but let's show off a bit here. Let's do it to the nearest tenth of a degree, 22.6 degrees. Okay. Yeah. Now, a lot of calculators, if you're looking for that tan inverse function, you can see it written underneath, and it's going to be in a special color, like it might be second function, it might be, I don't know, alternate, or so just play around with it. If you got a hand-me-down calculator, or you never kept the user manual, you can always look it up on the internet. There's tons of manuals around for all the calculators. So if you get to a dead end and you're not sure what to do, look up, grab the manual, hold on to that. It's probably a PDF file. One of the questions I always get as a math teacher is sometimes a calculator just gets hung up, like a computer sometimes. You get some weird character showing up and it doesn't, the buttons don't work right. Usually on the back there's a reset button, so that always works, but it's always a good idea to have the manual once you start getting into more complicated calculations like what we're learning today. Okay, so here's some homework questions. You can try out your new knowledge of the tan ratio and how you can use it to find missing sides or unknown angles. Okay, and then the next lesson we do, we'll be looking at other special ratios. It'll be very familiar to what we did today. We're just looking at the other sides. Okay, so have a try at that. If you're getting stuck on these questions, please join me on my office hours on Thursday this week. All right, guys, have a great day.